Hi, welcome back to this video series on cryptography. Today I'm going to talk about the cipher, which is one of the classical ciphers. Very interesting idea. Unfortunately, it is not secure for modern usage, but still the foundation ideas are pretty interesting. Okay, so what is the core idea of a cipher? Cipher uses a very simple modular arithmetic concept. Suppose you have a message that you would like to encrypt. All you do is, let's say we define our encryption function as follows. It takes two arguments, right? The key and the message. So E is the encryption function. All we do is basically we take our message and add X to it, K to it. K is the key, and we do it in mod some size. Usually in English alphabets, if you work with English alphabets, we set it to mod 26 because there are only 26 alphabets. We ignore non-alphabet characters. We don't distinguish between upper and lower characters. We model characters as numbers as follows. A is encoded as 0, B to be 1, and so on, all the way to Z to be 25. Okay, there are 26 total number of elements. Okay, so this is basically how we encode. Say if you want to send a message to someone, say Alice wants to send a message to Bob, hello. She has to look into the table, right? And she first has to encode the meaning of hello in terms of numbers. And then, of course, both Alice and Bob have to agree on the key K at the beginning. Then Alice will take the number, add K to it. Bob will just, let's call this Y, okay? Y is the ciphertext and the X is the input message. So how will the decryption process work then? The decryption process will just take the same key, of course, and the ciphertext Y, and all the recipient has to do is take the Y and subtract by K. You can see for yourself why this is correct easily, because Y is same as X plus K, right? So we are subtracting K. That means we will cancel out K. We will be end up with the X. After decryption, we will be having X for sure. That's basically the idea of the cipher. There is some historical reference that Caesar cipher used K to be 3. Okay. Anyway, so let me take a small example now and show to you how this cipher actually works by just running a simple example. Okay, so let's say Alice wants to talk to Bob using this scheme. They already agreed upon the key K. Okay, let's say Alice and Bob agreed the key to be as simple as K equal to 2. Okay, to be the key. Suppose Alice wants to send hello to Bob. What will she do? She will go into this table and look at A to be 0, B to be 1, and so on. And she will then encode her message. Encoding is different from encryption, just translating the alphabets into numbers, right? Otherwise we can't do plus and things like that. But all of the numbers, let's say she prepared a table, right? And she would be having H, E, L, L, O mapped to some numbers. I don't know. I'm just going to make a number because I have not counted really. We can also run a program later. So it's going to just make, let's just take it simple. Let's say H is say 8. I'm terribly long with this, but it's okay. E to be 5, L to be say 11, and another L is 11, and O to be 15. Just like take this example. All Alice is doing is she's going to take this 8, 5, 11, 11, 5, add 2 to each of these. That means essentially we can also forget about the numbers. We can just look into H. Where will H go? H goes to 2 characters after. What is H, I, and J? So H will become J, right? What about E? E will become G. So we can, this is much easier. What about L? L will go to N, right? L will go to N. And the next L will also go to N, of course. Therefore, we are almost there. And then O will go to M, N, right? O, let's say L will go to M and N. O will go to PQ. Okay, so this is basically the ciphertext. Excuse me. Alice will send to Bob J, G, N, and Q. So all Bob has to do is now do the opposite, subtract 2 positions. So he will be able to go back. from here all the way to the initial plain text. Okay, assuming the man in the middle is not tampering with the ciphertext, the crypto system successfully encrypts and decrypts. Okay, that's a very nice property. There is nothing specific about 26. You can actually increase your size of the vocabulary, size of the alphabet if you want. But if I'm working with only in English alphabets, therefore I put it 26. Okay. So what is big problem here? As you can see here, it leaks information. For example, we do know when two adjacent characters, for example, here is N and here is N, that means we know the corresponding plain text must be the same. That's clearly one information leakage. But even more serious is that suppose you don't really know the key as an attacker, that's the case. All you're going to do is you're going to take J, G, N, N, Q and start doing brute forcing all possible key. In the case of the Cipher cipher, the key space is only from 0 to 25, which means there are only 26 possibilities. So you can write a little for loop, keep trying this decryption function for all possible k, and see whether you get anything meaningful. Then you say, yeah, I found the text.